All right. All right. Good evening, everyone. My name is Emmanuel Mbemena. I'm a cybersecurity professional for some years, right? For some years. So today we'll be looking at, I hope you, first of all, I hope you had a good day. I know today is Friday, so today might be a stressful day for some people, while today might be an interesting day, pre-Valentine and all. Yeah, but I hope you had a good day. I did on my end. So without wasting more time, we'll go straight to today's topic in this boot camp. So we'll be looking at networking or introduction to networking. Uh, Look, can anyone tell me? I can see we're quite, maybe some people are still joining. Okay, well, I would just say, let me just start by introducing what networking is or sharing my experience with networking. So you might think, okay, we are doing, or we are discussing cybersecurity. So what does networking, have to do with cybersecurity? Um, so networking is a very interesting and very critical part of cybersecurity, or not just cybersecurity, everything you do, you listening in on this call, on this Zoom meeting, you maybe getting on YouTube, TikTok, whatever you do, social media, everything is based on networking. And without networking, all those things won't be possible. So as we go further, you would get to understand how all these things work, and then while we're actually reviewing or doing networking. So there are some people that if you don't start your cybersecurity journey right, you would see yourself skipping networking or the basics of networking or networking concepts, and then just doing like some other things in cybersecurity. Then when you land a role or get a job, if you do in the cybersecurity space, you would see that you're struggling with certain things that you ought to know. You're struggling with understanding what a subnet is, understanding those concepts. You're struggling with troubleshooting when there's an issue, when they say this is a hacker's IP address, it's coming from this domain, it's coming from this and that. You would not really understand most of those concepts that you need to know. So this is why it's critical to really understand networking before you maybe go in depth in cybersecurity. So no one is saying you should be an expert in networking, because there are people that are experts in networking. So there are people that are network engineers, there are people that are network security professionals. So those people typically handle firewalls in, again, I want to assume we know what firewalls are, or at least what the concept of firewall is. But if we don't know, it's fine. Hopefully, as we go on with this networking, you would understand what a firewall is and what it does. But yeah, there are some people that networking related stuff is what they do in organizations, and they work hand in hand with cybersecurity professionals, because you need them. You can't do without the networking people or people in networking. So, without wasting more time, I would share my screen and then we would get started. So, excuse me. Yeah, I just wanted you to see the essence of this session, and it's really important you listen carefully. When you have questions, please do not hesitate to ask. Okay, so I'll just share my screen. Just give me a moment. 1 minute, please. Okay. Let me share my screen. Okay, please confirm you can see my screen.
Yeah, we can.
Okay, all right. So I'll be using this. This is a very good platform for learning some stuff. So I'll be using this to like take us through the networking. So what do we typically understand when we say networks or networking? So networking is basically um things connected together. So it's again from the basic English language. When you hear network, is things connected. So your network of friends, your network of maybe professional colleagues. So it's just basically um people or things connected because of they have similar interests and all. But now in terms of computing, it's just the connection of different technological devices. So, for example, your phone connecting to maybe TikTok, connecting to YouTube, and all of that. So those YouTube as a platform is hosted on a server, or YouTube on its own is um, it's an application that's running on a server. So for you to be able to access YouTube and all of that, networking is what makes it possible. So basically anything that happens digitally, for it to work, it's because of the concept of networking. So you can just see this diagram. If Alice wants to send Bob a message, or Jim wants to send Bob a message, whoever wants to send themselves a message, networking has to play a vital role, whether email or you are, whatever you want to connect, whatever means of communication it's happening. Networking is really key. So, um, what is the internet? So we've understood the concept of the internet. So, sorry, we've understood the concept of network when we talk about networking. Now, what is the internet? So again, the internet is one giant network that consists of many small networks within itself. So that's the internet. Again, this same diagram explaining how people connect or communicate with each other on the internet. Okay. Yeah. So looking at this now, this is the internet. So the internet enables us to communicate from one network to another. So the internet basically helps different networks to communicate together. So again, this network could be a network of maybe an organization. This one could be a network, maybe my home. This could be a different network. So what enables them to be able to send information from one different logical location to another is the internet. So with this internet, there is communication of multiple networks. So again, this is just a little diagrammatic expression, but the internet is way more than this. So it could be billions of connections, billions of different other networks connecting together. So the internet is what makes it possible. So all these small networks are called private networks. But when this small network starts connecting to the internet, then it becomes a public network. So the internet, you call it public network. So when you hear things like public IP, it has to do with the internet. It's going through the internet. So it's leaving um, one location to another network location. So, okay, so now that we've sort of understood a bit of the concept of network and internet. Now let's look at identifying devices on a network. How do we identify devices on a network? So um, again, every device on the network, just similar to human beings, I have a name, you have a name. How do we identify ourselves? How do we know who is sending what information to who? If Vivian sends me a message, how do I know? Okay, obviously it's if I'm communicating with Vivian, she's sending me a direct message by talking to me. But if your phone is sending or wants to send me an information, how do I know that this is coming from you? Again, um, this is where an IP address and a MAC address comes to play. Okay, so every device, every digital device has a MAC address. So think of it as a serial number. So your laptop, your phone, your iPad, your your desktop, your whatever it is, most of them have a MAC address. So the MAC address is what you use to identify that device. What you use to identify the device. Also, it has an IP address. So every device has an IP. As long as it's connected to a network, it will have an IP address and a MAC address. So you might be asking, what is IP address? So at any point, if because I might like this IP address, it just stated IP address here, but it's just occurred to me that some of us might not know what the concept of IP address is. So an IP address basically means IP means internet protocol. So again, it's a protocol that happens on the internet. It's a way of identifying a host on a network for a period of time. So when they say a host can mean anything. A host on a network. Remember the concept of network. Network could be your house where you are now. That's like a network. So how do I identify a host? A host is any of these digital device, your laptop, your iPad, and all of that. So IP address is the way of identifying the host on a network for a period of time, where that IP address can be associated with another device without the IP address changing. So if for example now your phone that you're using to or your laptop you're using to have this meeting has an IP address, and an IP address looks something like this. So it's basically contains 4 octets. You can see here we have this is an example. Again, we would see more examples as we go forward. This is 192.168.1.1. This is what an IP address looks like. So it could be 1.0, I mean 10 or 111.2.3, but an IP address cannot have more than 3 characters. So it can have less, but it cannot have more, like per octet. So each of these is an octet. Again, I would look at what all of that means. But yeah, for every octet, you can't have more than 3 numbers. So you can't have 1,000 here, or you can't even have more than 255. Basically, not even more than you can't have more than 255. So 0 to 255 is what you can have here. 0 to 255 is what you can have here. 0 to 255 is what you can have here also. So you can't have more than 255, not 1,000. 1,000 is a lot. So if you see something like .257, that means it's a mistake. If you see 192.168 to 290, then that's a mistake. Maybe whoever wrote the IP address, maybe someone wrote it down somewhere or something. That's a mistake. So it's not supposed to be more than 255 per octet. Um, so the value of each octet will summarize the IP address device on the network. The number is calculated through a technique known as IP addressing and subnetting. But again, we'll discuss that another time as we go forward. We'll understand the concept of subnetting. What does subnet mean? Um, so IP addresses follow a set of standards known as protocols. So protocols are a set of standards. So without these standards, everything will just be chaotic. But with these standards, things are in place, or communication is easier because there's this protocol. Without rules, without all these protocols, everything would just be scattered. So that's why there are this set of standards called protocols. So they are the backbones of networking, and many of these devices understand the same language. So let's look at this example here. So this is, for example, my laptop. I could have this IP address 192.168.1.77. So again, this is what is used to identify. Your phone does not know that this is my name, or it does not know it's Emmanuel that is using this laptop. It just knows that this is the person I'm connecting to, that I'm talking with. That's what your phone or your laptop knows, that this is the person I want to speak with. It does not know that it's Emmanuel that is using this, but it knows that I'm speaking to 192.168.1.77. So this type of IP address is a private IP address. Um, I would explain the difference, and then we'll have another one to maybe on your end to your own laptop is using 86.157.52.21. This is a public IP address, and then these are different other devices, public, private. So you might want to you might want to ask, what's the difference between the public IP address or private IP address? How do you identify? So basically, anything that has 192.168, once you see 192.168, just know that, or once you see 192.168, just know that that is a private IP address. Also, if you see 10 dots something, once you see 10 dot something, 10.0.0, 10 dot anything, in most cases is a private IP address. But if you check your computer, you most likely see this 192.168. And I'm sure when we move forward, we'll get more explanation on that. So your public IP address is what your internet, there's what they call internet service provider. So for example, MTN is an internet service provider, Airtel, they are internet service providers. So they provide internet, and they you can identify, or your public IP addresses are given to you by your ISP. So if you search your computer and just type, I mean, if you search your browser and type, what is my IP address? It's going to show you your public IP address. So this is how your ISP knows, okay, you're in this location, and this is the device that is using this particular, or this is the person that is using this particular device and all of that. So um, your ISP is the one that assigns that public IP address to you. If you notice, even if you have 100 devices in your house or in your home, all of them will have the same IP address, except you have, again, you're using Airtel, and then you're using MTN, and your device is connected to either MTN or Airtel, then you have different public IP address. But as long as it's from the same, you're using the same router or the same broadband, or it's going to have that same public IP address. I mean, in your home where you are. So as more devices become connected, it's increasingly harder to get a public IP address that is not in use. Because, I mean, for example, Cisco, an industry giant in the world of networking, estimated that there would be approximately 50 billion devices connected to the internet at the end of 2021. So so far we've discussed one version of the internet protocol scheme, which is IPv4, which uses a numbering system of 2 to the power of 32. So which means this IP address can only contain 4.29 billion. So you can only get 4.29 billion of public IP addresses. But we obviously we have more than 4.29 billion devices. Even in just America alone, you have more than this number in terms of devices, more than 4.29 billion. When you're calculating phones, laptop, desktop, everything that typically uses an IP address is more than this just in one country. So why or how do we address, or how do they decide to address that issue? So this is where they now came up with, um, instead of using this IP version 4, which is Internet Protocol version 4, they now said, oh, they thought of something and said, let's do the IPv6, which is Internet Protocol version 6. It's a new Internet Protocol addressing scheme that has more, basically can cover more. You can see this IP address has 340 trillion plus. So before we before all of this is consumed, it's going to take years, like a long time. So this supports up to 2 to the power of 128 IP addresses. So, but right now, in most cases, you would see that, for every IPv4, you can easily convert IPv4 to IPv6. So this IPv4 IP address, this is the equivalent in IPv6. Um, this is the equivalent in IPv6. If you want to convert, you can just go online and search convert this IP address to IPv6, and you see the equivalent of that. So yeah, that's the concept of the IP address. So there are lots of public, and there are lots of private IP addresses. So in terms of, let me see if that's explained down here. Okay. So in terms of public IP address and private IP address, if someone should ask you, so what is the difference? So your if you have a MiFi, a router, either 4G, or whatever device it is, that device has a public IP address. Then once you connect your laptop, your phone, your MacBook, your tab, your desktop to that public IP, instead of these your devices, individual devices having multiple public IP addresses, it just assigns a private IP address to each of those devices. So now it has reduced the need to now have multiple public IP addresses when we are saying that public IP addresses are scarce. So why would the 10 devices in your home be using different public IP addresses? So instead of that, you're making use of private IP address. So um you're using making use of private IP address. So the private IP address could be 192.168.0.1. That could be the private IP address of my laptop. The one of my phone could be 192.168.0.2. The next one will be .3, like that, .4. But all of them are tied to one public IP address, which is coming from that router or that MiFi or that your SIM card that you're using to connect. So again, as we move forward, you would understand the concept more. So we talked about MAC addresses, where we said that all devices on the network will have a physical network interface, which is a microchip board that is found on the device's motherboard. And this network interface is assigned a unique address when it was built in the factory, and it's called a MAC address. So MAC means media access control. Media access control. So the MAC address is a 12-character hexadecimal number. That's a base 16 numbering system used in computing to represent
Emmanuel, please
numbers.
hold on. Emmanuel, sorry
Yeah.
for cutting you short. Oasis, what's your name? Kindly mute your mic. And please change your name to your real name. Can continue, Emmanuel.
Okay. Yes. Um, so we can see that these columns are considered separators. For example, this is a MAC address. The first 6 characters represent the company that made the network interface, and the last 6 is a unique number. So this first 6 is the vendor who builds the network interface, in this instance Intel, and then this last 3 is the unique address of the network interface. So this can, I mean, you can generate a lot um MAC addresses. For example, because it covers from, I think, from A to the hexadecimal, I think it's from either A to, is it A to G or so, yeah, or A to F. Yeah, so this could be A A1, A2. So again, because you can use letters and numbers here, this can be, I mean, it's a lot. If you do it mathematically, this is a lot. So it can be AB, 1B, 2B, 2D, 2C, 1F, 9. So whatever it is, this can be any combination. But yeah, the first three is just identifying the vendor. So if you see most, maybe for example, most HP laptops or so, most of them will have the same, for the first three, they might have the same, um, letters and numbers, but these other ones will now be quite, very different. But most devices, or all devices have their MAC address. If you look at if, for example, if you're with your laptop or your phone now, you can always check your MAC address either on the body of the device, or if you go to settings, you should be able to see under the networking, you should be able to see the MAC address of your device. But there's an interesting thing with MAC address is that MAC address can be faked or spoofed. So that when it's spoofed, the process is called spoofing. So when spoofing occurs, the it means someone is changing their MAC address to carry the MAC address of another device. For example, if I want to do something malicious on the internet, I'm going to, just because remember that IP address can trace the device that carries out an action. If I go to hack a bank, maybe an Access Bank or a GT Bank or whatever bank, and I don't spoof my IP address or my MAC address, I don't do anything. I just maybe carry out whatever damage I want to, they can trace it back to me, because it's if they have good security tools, it records the IP address that performed the hack or the attack or the breach or the stealing of data or whatever the case may be, and also the MAC address. Remember that when devices are communicating, when I'm using my laptop to hack another laptop or another server or any of that thing, it's not saying Emmanuel is hacking your server or Emmanuel is trying to steal data. It's saying this device A4C3F085AC2D MAC address with IP address 86 dot 86.157.52.21 is trying to steal data or whatever. So that's what it's going to say. It's not going to say my name. But once they're now doing forensics or investigation, they already have those details. If they now, that's how EFCC, I mean, can catch anyone that is doing any of this. What did they call it? If you're a, I don't want to use the general Yahoo or scammers or all of that thing, but sorry, excuse me, this is how they catch them. So once they have that during the forensics, they can now come when they pick up your computer and say, "Oh, we trace that this is coming from you." Once they check your device and see that this MAC address and the MAC address especially, because this one is always constant. If they check it and they see that it's the same, then you can't deny that you didn't perform the hack, except maybe someone took your laptop from you and then did that. Which is why in most cases, when threat actors or hackers or people want to do any of those malicious acts, they always spoof or change their IP address. So that's like the main thing. If you don't do that, then you're going to get caught. So there's a way to manually do this. There are tools that you can use to do this, but there are even ways you can automate it so that it's always changing. Sometimes you don't just want to use one MAC address so that it's difficult to, I mean, so that it's easy to track you. Like for those that are committing any of these malicious acts. So what they do is they use random MAC generators. So those random MAC address generators always generate MAC addresses like in seconds. It could generate maybe almost five or so in just a second. So it just keeps switching MAC address so that it's difficult for you to track where that or what device is committing that act. So places such as cafes, coffee shops, and hotels often use MAC address control when using their guests or public Wi-Fi. So this configuration could offer better services, that is faster connection for a price if you are willing to pay the fee per device. So yeah, so this is just talking about interactive lab. Okay. So some of these questions here, after this session, some of these will be assignments where you go and then you just answer this question. So once you, for example, if I answer this question and the answer is internet protocol. So once you answer it, you just click on check. It's going to check it. It's say correct answer. So um I'm going to tell you how to do. So this might not be how you do the assignment, but you would answer these questions here. So it's just going to help you to learn better. Then the next one is ICMP ping. I'm not sure this is the best time to discuss this concept. So I will not discuss this concept now. Move forward. Um, okay. Also, not discussing LAN. Okay, maybe let me discuss LAN. So LAN means local area network. So LAN means local area network. Um, there are two, more than two. There are two different types of network topologies. I don't want to discuss topologies. So there's the local area network, which is LAN, and then there's another one they call WAN, WAN, wide area network. Um, so these are things you need to you can read just the different types of um so that we don't I'll just go through the important stuff. But again, some of these are just good for you to know. So again, bus topology, star topology, this just shows how how you can arrange um, different devices on a local network. So explaining what LAN is, let's see if this so over the years, there's been an experimentation and implementation of various network device designs. In reference to networking, we refer to the term topology. We are actually referring to the design or look of a network at hand. So there are different advantages to different network topologies. But let me explain the concept of LAN and WAN. LAN means local area network. WAN means wide area network. I think those are like the two most important ones. So what you need to know is that LAN is just network um in a particular either logical area or physical area. For example, your company, your laptops, not your laptops, your your desktops, your laptops, yeah, they can be said to be connected to a LAN while once it has internet. So any device that's connected to the internet is automatically connected via WAN, wide area network. So just look at it like that. E- For maybe me here connecting to you or discussing with you, that's already like a wide area network. Anything that has to go through the internet is already a wide area network. But if it's located just in one location, then that is a LAN. For example, now if I can send something from my laptop to my phone without connecting to the internet, without having internet connection, because um logically I'm in the same local area network. So if my internet finishes, I cannot connect to the internet, but I can still send things from two devices in that same network, in the same local area network. So again, I'm sure as you go further, you will learn how this is done. But just have that in mind. One has to do with internet connectivity. So if two buildings, let's say this Access Bank branch wants to communicate to another Access Bank branch, they have to go through. It's like a WAN. That communication is a WAN, or that type of network is a WAN, because you can't really communicate from that place, physical location, to the other one without having internet, except there is a wire connected from that place to the other branch, which in most cases it's not the case. So it's going to be a one type of connection. I'm sure. Okay, so let's go to Okay. So, still on, there are some things that I've already explained. I would just, so sorry if when you have any question, you can ask at any point in time. Just call my attention. So there is a very important concept that I think you should know in all of this when it comes to networking. The first thing is the OSI model. You need to, without understanding the concept of most of us when we started cybersecurity and maybe IT, we just knew or we just heard the OSI model, but we didn't really understand the concept of the OSI model. The OSI model is, once you understand the OSI model, you'll be able to troubleshoot any issues relating to network or any issue basically in cybersecurity. You'll be able to troubleshoot. You'll be able to know this is where the problem is coming from. If, for example, now I'm talking on this Zoom and you can't hear me again, it has to do with something related to the OSI model. So it's now you that has to figure out what's the problem, where is the problem from. So again, as we go further, we'll understand that. Then there's the TCP IP model, which is like a spin-off of this OSI model. And so we'll also look at these models, how they look in practice. Then we'll look at some basic networking tools. I know I've mentioned firewall, switch, and all of those things. So you would now understand what those tools are, what those solutions are, and what they do. Okay, so the OSI model, or the OSI, means Open Systems Interconnection. That's what OSI means. So you need to take note of this. Typically in some exams, I don't think, well, in some exams, I think you will still see this. There's maybe networking exams, but maybe not necessarily in cybersecurity exam. But if you're writing any networking exam, you would see this, what's the meaning of OSI? So it's Open Systems Interconnection model. So it's a standardized model which we use to demonstrate the theory behind computer networking. So again, we are demonstrating the theory. The theory. Everything I've been saying so far has just been theory. I've been saying, oh, IP address, this is how it work. But now I told you that from my computer, for me to be able to have this, for me to be having this Zoom call with you, is because everything in the OSI model works as it should. So in practice, it is actually more compact. It is the more compact TCP/IP model that the real-world networking is based off. However, the OSI model in many ways is easier to get an initial understanding from. So the OSI model consists of 7 layers. So take note of that, 7 layers. The first one is the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, the physical layer. So it starts from the ground up. You know, when you're building a house, you don't start from the top. You build from down to the top. So that's how it works, from the down to the top. So I would explain how that works. So there are many mnemonics for floating around that can help you learn this or at least master it, because sometimes they might ask you, oh, can you list the OSI, the what the OSI consists of, or the different layers of the OSI model. So you might forget some of this, but there are ways to remember it. For me, like when I learned it, I knew apps, like application. So that's APS, app. So I knew application, presentation, session. I already knew that was the order: application on top, presentation, session, because of the first letters, APS, apps. Then these other ones, again, I just knew that the shons are up. And when I know it's apps, I know application, presentation, session. So I already knew these shons were up. Then I knew that the middle one was transport. So from that, these ones are pretty easy to remember: physical, data link, and network. So people have different ways of remembering this, but I think once you understand the concept of what this does, you will not even need the mnemonics, or you will not need to say all these Axonius, Pale, Shakespeare, blah blah blah, to remember this. You just know, you just remember it automatically. So let's look at all of this in turn. So the layer 7, again, remember I said this from the ground up. This is 7, 6, 5, 4, 3, 2, 1. So for layer 7, this is the application layer of the OSI model. Essentially, it provides network options to programs running on a computer. It's almost exclusively with applications providing an interface for them to use in order to transmit data. When data is given to the application layer, it is passed down to the presentation layer. So the presentation layer receives data from the application layer. Then the data tends to be in a format that the application understands, but is not necessarily a standardized format that could be understood by the application layer in the receiving computer. The presentation layer translates data into standardized. All these things are English. So looking at the application layer now, let's use Zoom for example. When you when you um when you want to join a Zoom meeting, what do you do first of all? You look for your Zoom application. That's the first thing, and you click on it. So that Zoom application is what you can see there is the application layer, what you can visibly see. That's the application layer. That's what we can see. If you want to join a Zoom meeting, we are looking for Zoom. That is the application layer. Okay, so it's the interface that we are using. All right. Then the next one is the presentation layer. The presentation layer is uh, is just saying, okay, now we have the Zoom layer. Sorry, we have the Zoom application and we can see it. But it needs to be in a format that it needs to be in a format that the entire networking concept would understand. So I would explain that presentation might be tricky to explain at this point. Let me start from the ground up. I think that would be better so that I will not start from the top. Again, we are building from the ground. So the physical layer is as the name says, is the physical stuff, something you can touch. So for me to join a Zoom meeting, I have to bring out my laptop first, right? I have to have a phone. I have to have a tab. Without that, I can't even have the Zoom meeting in the first place. So that first layer is the physical layer. You need to have that device to initiate that communication. Okay. So that's the physical layer, your laptop which you're using. So this is where electrical pulse, make up data transfer over the network, blah, blah, blah. So that's the concept. So for you to join the Zoom meeting, you need that laptop. Then the next thing is the data link layer. So the data link layer focuses on physical addressing of the transmission. It receives a packet from the network layer that includes the IP address of the remote computer and adds in a physical MAC address at the receiving point. Inside every network enabled computer, there's a network interface card that comes with a unique MAC address control to identify it. So yeah, the data link layer, this is my laptop. Remember I said that every laptop, every phone, every device, they have what they call they have a MAC address. So the MAC address is imputed or is embedded on the network interface card. Okay. So that's so now on this my laptop now, if my network interface card is like a chip, it's like a hardware on the laptop, if that thing is bad, then there's going to be a problem with my laptop. I'll not be able to connect to the internet. I'll not be able to connect to any network because it's bad. So MAC addresses are set by manufacturers and literally burnt into the card, so they can't be changed. You can't change the MAC address of your computer, like physically. You can't change it. You can only spoof them. That's just change them to um look like it's coming from a different MAC address. But the main thing is that when they take down your computer, they can easily see the MAC address that this is it. This is this MAC address, but you can't physically change it. Um it's just like, it's just like you can wear you're a woman or a man, you can wear the clothes of a woman, a man, you can wear the clothes of a woman, but it doesn't change the fact that you physically are a man. Maybe that's not the best example. It's what's happening today. But yeah, that's the concept. So it's still you're still a man or you're still a woman, even though you wear a different cloth. So just to change your appearance, put makeup and all of that. But if someone knows you in depth or someone wants to check, they can easily know that okay, this is who you really are. So that's the concept of this MAC address here. So the job of the data link layer is to present the data in a format suitable for transmission. So the data link layer also serves as an important function when it receives data. It checks the received information to make sure that it hasn't been corrupted during transmission, which could happen when the data is transmitted by layer one, which is the physical layer. So this data link layer says there's Emmanuel wants to connect to Zoom. So it's picking up my my MAC address. Sorry, it's picking up my MAC address and saying this person wants to connect to this application. So it already knows who is connecting to this Zoom. Then the next thing is the network. So the network layer is responsible for locating the destination of your request. For example, the internet is a huge network. When you want to request information from a web page, is the network layer that takes the IP address of the page and figures out the best routes to take. So at this stage, we are working with what is referred to as logical addressing, that is IP addresses. So this network address, your home router, your broadband or whatever you might know it as, the network layer, that is an example of the network layer. So if I want to join this Zoom is an application hosted on a server. So I want to connect to that Zoom. I have my MAC address, I have my IP address that I've gotten from my router or my SIM card or whatever device is giving you internet connectivity. So you already have an IP address. So that's the network layer. So moving to the transport layer, the transport layer is a very interesting layer because the first purpose is to choose protocol over which the data is to be transmitted. So you want to transmit data. The transport layer is what is going to transport the data. So there are two main protocols under this transport layer. One is the TCP, which is the transmission control protocol, and then the other one is UDP. So you can see TCP is transmission control protocol. It's a connection oriented protocol requiring a three-way handshake to establish a connection. TCP provides reliable data transfer, flow control, blah blah blah. So while UDP does not require a connection to be established. UDP is suitable for protocols that rely on fast queries such as DNS and for protocols that prioritize real-time communication such as video and audio. So when streaming something, when you want to stream something, it's going to be using UDP. When you need some, maybe you're sending an email, in most cases, it's going to use TCP. So UDP is just saying that for example, now you're watching Premier League football on DSTV. If if maybe NEPA takes lights or something, it's not going to pause at that point where you're watching it because it's live. It's you've missed it, you've missed it, you've missed that 1 second or that 2 seconds before you switch over to the gen. It's because it's running on TCP or it's based on TCP, where sorry, it's based on UDP, where once you lose, so just like if I'm saying something now in this meeting, I'm using UDP for this audio and also for the video. So once I've said something and you missed it, maybe your internet got cut off, you've missed it because it's UDP. But TCP is different because TCP your message has to go through. You have to, the person you are sending that message to or communicating to has to receive it. So if it fails, if anything fails, TCP will retry sending it again. So let me just give an example or a human example of what TCP and UDP looks like. So I want to buy something. Let's say I want to buy biscuits, and I just call my brother and I say, maybe I say, hey, Ibuka, help me get biscuits downstairs. and he hears me when I say that. He says, "Okay, I'll get it." And then he goes to get it, and he comes and he gives me the biscuits. So he heard me, he carried out the action and reported back with the action. That's how TCP works. But for UDP, I can say, "Hey, Ipka, help me get biscuits." He might hear me, but he's not going to say, "Oh, I heard you." He might just do it if he heard me without telling me, "Oh, I heard you. I'll go and buy it." He might just go and buy it, and then I wouldn't even know he bought it. Maybe you buy it and just keep it somewhere. But he heard me, but he didn't let me know that he heard me. So when you hear the concept of three-way handshake is I would have loved to. There's what you call scene arc. Maybe that's maybe I don't want that. I don't want to I don't want to introduce any complicated concept at this time. But yeah, so it's just there's a communication, then there's an acknowledgement, and then there's a feedback. So that's what they call the scene, the acknowledgement, and again the scene. So that's the three-way handshake. So where someone says, I first say I'm the first person, then the other person says, I tell the person, "Oh, please go get me biscuit." The person says, "Okay." The person acknowledge that, "Oh, I heard you. I'll go get it." And when the person gets it, he says, "Oh, I've gotten it." Then that's him acknowledging, and I say, "Oh, thank you." So that's the three-way handshake. But for the other one, the UDP just it doesn't use the three-way handshake. So when I say go and buy this, maybe he's in the room and I'm in the sitting room, or he's in the bedroom, and I say, "Hey, go get me this." He will not say, "Oh, I heard you, I'm going to get it." He might hear you and just carry out the action, or he will not carry out the action. So with UDP, there's no way you know if the action or what you're sending has gone through compared to TCP. So your WhatsApp message works based on TCP. You sending message to your mom, your dad works based on TCP protocol. Where if you are sending a message, hope you are doing fine, is sending that message. When it sends the message, you see that blue tick, which means it has sent. If it does not send, it's going to notify you. It's going to notify you that, "Oh, this message has not sent." That's when you see that. Again, all these things are just you are seeing it that there's no blue tick, or it's still rolling, or it has not given any tick at all. That's not giving tick is because there's a TCP protocol that is saying that you must report back on your action. If my message has not sent, report back to me that it has not sent. So that's when you see that it has not ticked, because it has reported back to you that for some reason this has not sent. So maybe after a while, when it now sends, it's not going to tick and say, "Oh, I've sent this message." That's because it's TCP. If it's UDP, you're not going to see any of that. If you send a message, "How are you doing?" you will not know if it has sent or not. It's not going to tick or not. You will not just know. So again, what's important that you take note of is that for UDP, you see UDP protocol being used in audio and video, where once someone is saying something like a live stream, and you missed what the person said, you can't get it back except maybe you record it. But at that moment, it's using UDP. So a TCP connection allows two computers to remain in constant communication to ensure that data is sent at an acceptable speed, and that there's and and that any lost data is resent. Again, this is where I gave you the concept of WhatsApp. So it's going to make sure that it sends that message or gives you feedback if it has not sent. And then as long as there's internet, it's always going to try to resend that message. While with UDP, the opposite is true. So packets are essentially thrown at the receiving computer. If it can't keep up, then that's its problem, which is why video transmission over something like Skype can be pixelated if the connection is bad, which means that, which what this means is that TCP would usually be chosen for situations where accuracy is favored over speed. Again, this is important. TCP is used when accuracy is favored over speed. I want to send a file from my laptop to my phone. TCP is being used because it's sending a file. I want to make sure that that picture I'm sending from my phone to my laptop sends correctly. Why do you think when you send a picture from one place to another, maybe you're sending a picture from someone, your WhatsApp to the another person's own, it's not broken or it's not divided into pieces or looking somehow? It's because it's using TCP, and it will make sure that it's going to send that picture as it is. So, and it's going to make sure it completes that. But for UDP, it can break in connection, and then if we are using UDP for that kind of communication, you might just receive the image and you'll not be able to view it, or it will just be scattered. It will look somehow. So again, TCP is used for file transfer. When you're sending emails, TCP is used because you want to ensure that that email gets to the person, and it gets to the person with the right words, right, the everything, the way you sent it. So again, loading a web page, me opening this browser and all, is because it's using TCP. While UDP will be used in situations where speed is more important. So when you're video streaming, you need to use UDP. If you use TCP, it means as maybe as you're playing match, it's just going to be stuck at maybe 1 minute, trying to show you everything that happens in 1 minute. So let's say there are two corner kicks in that 1 minute. It's going to make sure it shows it to you when in actual essence, in what is happening in real life, they've passed that stage. So again, you would understand all these concepts when you go further and get more examples. um mm, Sometimes networking could be challenging to explain, but when you go further and get more resources, you would also get more real life understanding of that. So session. So what is session? So when session layer receives correctly formatted data from the presentation layer, it looks to see if it can set up a connection with the other computer across the network. So if it can't, then it sends back an error and process goes no further. If a session can be established, then it's the job of a session layer to maintain it, as well as cooperate with the session layer or remote computer in order to synchronize communication. So the long story of this is that in relation to this, our Zoom example, excuse me. So I want to connect to this our bootcamp session. Not connect to this our bootcamp session via Zoom. So why do you think I'm not connected to the wrong Zoom meeting? Why do you think? Because right now there are over, I can promise you there are over maybe 500 Zoom meetings. As if I'm not, I don't think I'm even exaggerating. There are over 500 Zoom meetings happening around the world right now as I'm speaking to you. There are over 500 Zoom meetings. Why am I not connecting to the one in London or the one in USA? Why am I connected to this specific one that we created? How come I'm able to connect and we are all connected to this particular one? It's because of session. So the session is what keeps both of you connected. So there's what they call session ID. So for you to connect, there's that session ID, which is this ID that we use to maybe use the ID or the password. You might, for those that just click link, it's still the link somehow has those session ID or those session details. So that's what says this session 19234 is for Nexsecure's bootcamp meeting. So it's not for Deloitte's meeting in London. It's for Nexsecure meeting. This session ID again. We are not just looking at the ID we are seeing for the Zoom. It's just the system, the Zoom system already understands that at the back end, that because you're using this ID means you want to connect to this meeting. So that's the concept of session ID. So for every aside this Zoom explanation, for every communication that you're having, for me to be able to have a WhatsApp video call with you, is because at the back end of the WhatsApp, there's already a session ID that has been established, that Emmanuel wants to call his brother at this time, and he has initiated that call. So it's going to have a session ID that would be sent to the other device, and the other device will say, oh, this is coming from Emmanuel. So it's just going to establish that session. So when session layer has successfully logged the connection between the host and the remote computer, the data is passed down to layer 4, which is the transport layer. So So that's the session. Then the presentation layer receives the data from the application layer, and this data tends to be in the format or that the application understands, but is not necessarily in a standardized format that could be understood by the application layer in the receiving computer. The presentation layer translates data into a standardized format, as well as handling any encryption, compression, or any other transformations to the data. With this complete, the data is passed down to the session layer. So presentation is just how the data looks like. So we are having this session is because it's presenting it to us the way we want to see it. It's presenting it to us in text. It could be in audio, whatever it is, whatever type of. Again, all these are just data. So that's what the presentation layer is in charge of. So we would, I think there's also a better way of, let me see. Mm, encapsulation. So this is also another interesting concept of um, networking. So as data is passed down each layer of the model, more information containing specific details to the layer in question is added onto the start of the transmission. As an example, the header added by the network layer would include things like the source and destination IP address, and the header added by the transport layer would include, amongst other things, information specific to the protocol being used. The data link layer adds a piece at the end of the transmission, which is used to verify that the data has not been corrupted on transmission. So, what are we talking about here? So, we are looking at the different layers. So, looking at this stage one, which is, or let's start with this stage 7 here. So this is saying this is just, again, this is your physical laptop, and the data, this is data stream in bits. So everything that is happening, any touch on your keyboard, all this, your keyboard, pressing keyboard, using your mouse pad, the computer understands it as bits, zeros and ones. So that's what it understands. Then it converts it to all these letters and numbers and characters. So when before it sends anything, um, it adds a layer 2 header, which is your MAC address. So it says Emmanuel who is using this laptop, again, does not know I'm Emmanuel, but it says this user, so it puts the MAC address. This user, so it's already identifying your laptop. This user wants to send data to this other user. So I want to send the data to you. I want to send something to you and information to you. So it's going to say this Emmanuel, who is using this MAC address, sorry, wants to send something to maybe Vivian. Then it's also going to say, it's going to add an L3 header, which is the data packets. It's going to say, what is the IP address that Emmanuel's that this MAC address is using. So it's going to also add the IP address to the message that is sending. So aside the message that is sending, it's going to add the L4 header, which is the data segment or datagram. So it's saying, are you using TCP or UDP? So it's going to add that also to the message. And then the session layer 2 is going to add that. Then when it comes here to the main data, it's going to show the data. Again, all these are just data, because it's presenting it's presenting the data at this point, like what you want to see. But basically, when you're sending any message to anybody, it's going to pick up your MAC address, your IP address, and then the protocol that is going to be used depending on type of data. So it says, notice that the encapsulated data is given a different name at different steps in the process. In layers 7, 6, and 5, the data is simply referred to as data. In the transport layer, the encapsulated data is referred to as segments or a datagram, depending on whether TCP or UDP is being used for the transmission protocol. So let me see. So when the message is received by the second computer, it reverses the process starting at the physical layer and working up until it reaches the application layer, stripping off the added information as it goes. So this is referred to as the encapsulation. As such, you think as layers of the OSI model as existing inside every computer with network capabilities. So um, computers all follow the same process of encapsulation to send data and encapsulation upon receiving it. So as you're receiving that information from me, you know it's coming from my MAC address, my IP address, and the protocol I'm trying to use to send it depending on data. Then when you're sending it back to me, my computer is going to remove all those headers. Um, I think the explanation that I used to understand this concept was just like a mailman when someone wants to send a mail, physical mail, an email on an envelope. What you see there is it's going to have my name. So if I want to send a letter to maybe Vivian, a handwritten letter, it's if I'm taking it to the post office who's going to do the delivery, it has to have my name, which is my MAC address, for example. Then who am I sending it to? Where is this person address? Where is Vivian's address? Number 2 Tinubu Street. That address is the IP address. So it's now in the network layer, it's going to be pointing to her IP address. Okay. So now the mailman has this letter is coming from Emmanuel, which is a Mac. It has the detail. It's coming from his own address and it's going to Vivian's IP address. And then what's protocol is being used to send this, how do you want to send it? So again, depends on the type of, okay, this letter I want to send, I don't want anything to happen to it, so we are using TCP. Again, if it's audio type of letter, then again it's UDP. Then it gets to, then the letter is delivered basically, which is the data using, so there are different formats. Remember I told you the application layer is how it looks like. So again, we don't know how the letter looks like, but it's eventually delivered. So when it's delivered, for Vivian to also see that this is coming from me, she will see the address and all of that, my IP address. Um, she'll see my MAC address. Again, this is I'm trying to see how I explain it with the human concept and again the network concept. But yeah, that's how you that's how devices identify what is being sent, and that's how they break it down. Um, so again, the essence of all of this is just so that there's a standardized method of sending data. Without all of this, without this concept, messages will just be sent anyhow, and then it's just going to be chaos. So but with this now, when messages are sent, when things are sent, it knows, okay, this is coming from this person, this is coming from this person, this is going to this person, and all of that. So there's always what they call a source IP address and a destination IP address. If I'm sending something to you, the source address is IP address is my IP address. The destination IP address is who I'm sending it to. So that's what you can use to trace. So if there's any hack or anything, it's coming from a source IP address. If there's any data that has been sent away, there's a source IP address and there's a destination IP address where the data is going to. So that's also very important to take note of. Um, we just talked about the OSI model. Now there's the TCP IP model. So this model in many ways is very similar to the OSI model, although it's a few years older and serves as the basic for real-world networking. The TCP IP model consists of 4 layers: the application, the transport, the internet, and the network interface. So between them, this cover the same range of functions as the 7 layers of the OSI model. So you can see in this one, they removed the presentation layer, the session layer. So all the shons have been removed except the application layer. Then it has transport, then the internet, which is and then the network interface. So some recent sources split the TCP/IP model into 5 layers. breaking the network interface into data link and physical layers. The same with the OSI model. So this is accepted and well known. However, it is not officially defined, unlike the original four layers. So this is like the TCP IP model. So you can see here, this is the OSI. This is how the TCP IP looks like. All of these are just application. Then there's the transport. Then there's network, which is representing the internet, and then there's the network interface. That's the interface in which the internet sits on. So that's data link and physical uh, layer. See. Okay, so this was what I was talking about when I was talking about the scene arc and all of that. So this is the way TCP works. So as earlier mentioned, TCP is a connection-based protocol. In other words, before you send in data via TCP, you must first form a stable connection between the two computers. The process of forming this connection is called the three-way handshake. So when you attempt to make a connection, your computer first sends a special request to the remote server indicating that it wants to initialize a connection. The request contains something called the SYN, which is short for synchronize, which essentially makes the first contact in starting the connection process. Then the server will then respond. The server will then respond with a packet containing the SYN bits as well as the acknowledgement bits called ACK. So finally, your computer will send a packet that contains the ACK by itself, confirming the connection has been set up successfully. With the three-way handshake successfully completed, data can reliably be transmitted between the two computers. Any data that is lost or corrupted on transmission is resent, thus leading to a connection which appears to be lossless. So one thing that you should not forget is that with the TCP, it's connection based. That means there must be an established connection, and data is usually not lost with TCP. If it fails to send, it's going to resend. So remember, I gave you an analogy of maybe me sending my brother to get something. So this is client and this is server. All this me being able to access this website is because it's hosted on a server, or there's an application that is delivering this on a server. So let's assume now I told you that I wanted my brother to get something. I'll say, oh, Ebuka, please help me get something. So that means sending a synchronization saying to him, oh, help me get something. He says, oh, I heard you. I will get it. I'll get it for you. I say, oh, thank you. So that's the acknowledging, me acknowledging, oh, thank you for responding. So it's me sending message, the person responding, oh, don't worry, I'll do it for you. And then I say, oh, thank you. So that's the TCP. While for the UDP, the UDP does not have this, there's no SYN arc here. So once you send this to the person, the person can decide to do it or not. So you will not get this SYN arc, and you will not get this acknowledgement because you will not know if the person has done. So that one is almost like a one-way stuff. But it's not a handshake, because handshake has to do with more than with two people. So this one is just going to be almost like a one-way thing where you send this guy information and you don't know if he's doing it or not. So okay, so now it's important to understand why TCP. So you might be asking, why is this? Why is this relevant? What's the whole essence of all this TCP IP jargon and OSI model that we've been talking about since? Yeah. So initially, when everything started, there was no standardization. Different manufacturers followed their own methodologies, and consequently, systems made by different manufacturers were completely incompatible when it came to networking. So, for example, maybe HP laptops can only send message or communicate to HP laptops. Uh, Apple phones can only communicate to Apple phones and all of that. So they didn't want that to be the case. So they now said, okay, what can be a standard that everyone will use so that whatever information is being sent, the other person can receive it, even if the person is from a different company or the person has a different device. person will still receive that exact same information. So that is where they now came up with um, the TCP IP model, which was introduced in by American DoD in 1982 to provide a standard, something for all different manufacturers to follow. So this sorted out the inconsistency problems. Later, the OSI model was also introduced by the International Organization for Standardization, ISO. So I'm sure you must have heard of ISO. When you hear ISO, ISO 27001, ISO, blah, blah, blah. So that ISO is the organization for International Organization for Standardization. They're in charge of providing standards. Um, yeah, so yeah, however, it's mainly used as more comprehensive guide for learning, as the TCP IP model is still the standard upon which modern networking is based. Yeah, but the OSI is just for better understanding. Um, so looking at some networking tools, um, so ping, this is really important. So I'll just explain this like the way we use it. So in organizations, most times you see people using ping every time. When, for example, you cannot access the internet or something is wrong, you hear someone saying, "Can you ping that IP?" So the ping, when they say, "Can you ping that IP?" it's just them saying, "Can you see if it is reachable?" So at this stage, hopefully all the okay, blah blah blah. Okay. Yeah, so the ping command is used when we want to test whether a connection to remote resource is possible. That's a simple explanation of what ping is. Usually this would be a website on the internet, but it could also be for a computer in your home network. If you want to check if it's configured correctly, ping works using the ICMP protocol, which is so this is I think internet so is it something message protocol. What's the C again? So which is one of the slightly less well-known TCP IP protocols that were mentioned earlier. So this protocol works the ICM protocol works on network layer of the OSI model and does the internet layer of the TCP IP model. So the basic syntax to use ping is ping target. So you can just, if you go to your laptop and just do CMD, and if I say ping google.com, this is me checking if google.com is still active. If you, anytime you ping google.com and it's not reachable, it just means somehow you don't have internet or something. So you can see when I did ping, it's saying reply from this. It's showing me this address. Who can tell me what type of address this is? Who can tell me what type of address this is?
Shared it the IPv6.
Yes, thank you very much. So this is IPv6 address of Google. So it says reply from this. So it's telling me that it took it 27 milliseconds. That's less than a second to reply. And yeah, so once you see that it's replying, then it means you can reach it because this is over the internet. So I can reach that. If I can ping again, maybe ping cybersecurity.com or just any random network. As long as you're seeing getting replies, so you can see this one now is showing me an IPv4 IP address. But the main thing is that there's a reply coming from it, and it's showing me the time it took to like get response. So that's what ping does. So let me try. Let's ping something that does not exist. Let's see. Ping et.com. So you can see ping request could not find host. So it couldn't see anything like this. So that's why I said please check name and try again because there's nothing like this on the internet. Sorry, excuse me. Okay, sorry about that. Yeah, so if you ping let's say I ping another, so you can ping either they call these host names or domain names. You can ping that or you can ping IP address. So let's say I know the IP address I'm trying to reach. Let's say in my network I'm trying to ping 10.121 dot this. So it's trying to ping, and you can see it's saying request timeout. So once you see something like this, as long as it's not giving you a reply, then it's telling you that there's something wrong with this host you're trying to reach. So you can call it host or this device, because we don't know what device this is. We don't know what device is using this IP, so you can just call it host. So you can see it's trying to ping or reach it. It's saying, are you active? So that's what this ping is. Ping is saying, are you active? Are you on? Are you available? So once it's not getting any data, once you're not getting any reply, then there's something wrong. So the first thing, just take note of that. The first thing to do to see uh if there's connectivity with another um host or endpoint is to ping. So once you ping and you can reach it, then it's fine. For example, if someone is having internet issues and says, "Oh, I can't connect to the internet," or I don't know, it looks like my internet is bad or something. If you tell the person to ping, so the person can ping google.com. If the google.com is reachable, if it gives you that reply, then it means your own internet is good. But if, for example, now if I do ping google.com, then I put maybe /t. So the /t that I put is just going to make it to keep getting that response. Are you there? Are you there? Are you there? So it's like me sending continuous, are you there? Are you there? And then Google is replying, oh yeah, yes, I'm here, I'm here, I'm here, I'm here, I'm here. So that's what the -t is. So you can see this is giving continuous response. So this is because my internet is fine. So if I try to browse google.com on my browser, it's going to go fine. But if for some case of in some reason you're having, maybe as it's going like this continuously, it's timing out. You see maybe after the first two you see request timed out, then it continues, then again you see request timeout. It's just showing you that there's something wrong with that connection, that maybe your internet is not so strong or there's something disrupting the connectivity. So again, that's how you can test. So ping is always very useful, but it's used to check if a host is up. Again, remember the concept of host is any device, but in this case, we don't know the name. So in most organizations, in terms of network security, they disabled ping. So you can't ping internally and even externally, because the reason they did that is so that a threat actor will not come and then ping to see if a host or a device is up, so that they'll start their attack on it. So most times some organizations disable ping, or they disable it on some devices and maybe allow certain people to be able to ping. So that's the concept of ping. So ping is very useful. Then there's another one which is called trace route. So again, these are commands you need to know. Trace route just the logical follow-up of the ping command is trace route. So trace route can be used to map the path your request takes as it heads to your machine. So the internet is made up of many, many different servers and endpoints, all networked up to each other. So this means that in order to get content you actually want, you first need to go through the requested you first need to go through a bunch of other servers. So traceroute actually allows you to see each of these connections. It allows you to see every intermediate step between your computer and the resource you requested. So the basic syntax of traceroute on Linux is trace routes then destination. So trace routes, then you put the destination, either google.com or wherever you want to trace routes. It could be an IP, so it's not just um, a host name or domain name. Why on Windows you use trace set, on Linux you use trace route. So this operates using the ICMP protocol. So for example, now if I do trace routes, let's say I do trace sets, because this is Windows. So trace set Google dot, let me not use google.com, let's use ssrc.com. So this is going to show me the steps that the different hops or the different servers is hitting before it reaches this website. So if you see this first one now, it's saying MTN broadband NG. Because I'm using MTN broadband, it's going from my router. It's going to this 1041. This 1041 looks like a um this is a public IP address. Yes, so it's like a this is a public IP address. Yes, so this is a public IP address 10.170.129. So this also looks like, I think this is a private IP address. Hold on. So it's trying to reach this 181, which is this sccybersecurity.com public IP address or server IP address. But you can see it's going through different other servers. It's going to go through from my router to the ISP router to different servers. So this is routing before it eventually gets to this 181. So you can see how long it's taking in milliseconds. So this means that possibly if I'm trying to browse this sccybersecurity.com or this website, it might take a while before it reaches this website. So it's not going to be very fast. But eventually, I'm sure it's going to reach this 181. But yeah, it's going through different servers. So again, this is what you can use to test the routes or the connection, the parts in which a host, I mean the part before you reach a host. So you can see this is a lot of, some of these are firewalls and things like this. So let me just stop that. So you can see this one that was done for Google. You can see it went through different servers just before reaching google.com. So, but eventually, I think it eventually reached, yeah. So you can see it eventually reached the 21658. That which is the Google IP address, the IPv4 address. So you can see it took 13 hops to get to my router or gateway. So it took 13 hops before it got here. So it's hopping from one server to another server to another server before. It's just like I want to go to Lekki or VI from where I am. I'm not just going to appear there. I'm not going to appear in Lekki. I have to take maybe bus to CMS. Then from CMS, I take another bus to Lekki Phase 1. Then from Lekki Phase 1, I take on that bus to my office. So those are the hops. It's showing that. So those hops, those different buses are like the IP addresses you're seeing here. You're not just disappearing. And that's how communication works. So it could take, if maybe I'm going from maybe Keja to Aja, obviously that's going to take a long time to reach that route. But the different buses I'm taking are the different hops. And then there's a time it will take um, from the Keja to CMS. It will take me 1 hour, but in this case, you are calculating in milliseconds. Then from CMS to now Agile to maybe take 3 hours. That's on that time. Then from there to my workplace, going to take like 30 minutes. But in all of that, it's tracing the route in which you took for you to get to that destination, which is my workplace. So that's the concept of this. So if at any point something happens, maybe for some reason they block the entire route to go to Aja, then I'm not going to be able to reach this. You see there to tell you, just like this, where it's something. If I allow this, you can see this is already 21 hops. That's a lot of hops just to even get to this website. But maybe at some point it reaches this 22 and it's just showing timeout, timeout, timeout. Then it means there's a problem. I can't reach this guy. I'm never going to reach this office because something has blocked this place. So, yeah, that's the concept of trace route. So that's when you reach. That's when you use trace route or trace set when you want to see if there's any issues along the road or at what point the network is getting disrupted. So the another one is who is. So domain names. the concept of domain names. So names, these are the unsung saviors of the internet. So normally, the reason why this said this is you're saying, can you imagine how it will feel to remember the IP address of every website you want to visit? So this tryhackme.com, sccybersafe.com, nexsecure.com, nexsecurecyber.com, google.com, all those things are domain names, but your computer does not know what those things are. Your computer only understands IP addresses. It knows, like I told you, MAC address this, and with IP address this is trying to reach MAC address this with IP address this. It does not know is Emmanuel that is using that computer, or what this name is, or is SC Cybersafe. What he knows is the IP address. But because now, if I want to visit google.com, I have to remember that Google's IP address is 222.42.30. I mean, it's difficult for me to remember all of that. Or if I want to visit SC Cybersafe, I have to know that the IP address, or the way to access it, the address basically. Remember, I said IP address is almost like your physical home address, or it's just you want to reach somewhere. But for network, they use IP address. So yeah, I want to visit sccybersafe.com. I'll have to start remembering, oh, the address is 10.2.5. All of that. It's difficult to remember, but once you know the name, it's easier to reach it, which is why we have domains. So, and that's the concept of domain names. Domain names just help to make it easier to reach an IP address. So WHOIS essentially allows you to query a domain name that where a domain name is registered to. So if you let me just show you. Okay, so if I do WHOIS, so there are many WHOIS lookups. So if there's WHOIS.domain tools or WHOIS domain tools here, so WHOIS will give you information of who owns a website. Or so, for example, if I type sacybersafe.com and then search it, it will tell you, oh, this is the owner of the website, this was when it was created, and all of those other information. So you can see here it's saying is you can see here, this is the domain name. You can see when the website was created. It was created 2022. Then if you go down, you see other details like my name, the name of the organization, and all of that other information. Sometimes people will redact all this information because, for example, this one that has my phone number, you wouldn't want someone calling you or spamming you with calls or emails and all of that. So sometimes you can redact this information so that nobody sees all this information. But yeah, WHOIS just gives you information about the domain, when it was created, how long. So this website or this domain is 1,264 days old. It tells you the name servers and all of this. So this concept, all these name servers, these are concepts that you need to know. And I'm sure when you start getting ready for some of these, when you start taking more trainings on these concepts, you would get familiar with all those things. Yeah, so that's what WHOIS is. So you can see this. You can perform WHOIS on Facebook. All you need to do is just go to whois.domaintools.com, or there are different other WHOIS. So once you just say WHOIS, look up, you see different websites that can help you do WHOIS. There's whois.com. You can see there's whois.com. This website you can use. There's whois.domaintools. There are different WHOIS platforms. Okay, so personally, I just like the whois.domaintools. It. Uh, so another concept you need to know is this dig. So the- basically, this one helps you to again, it's relating to domain. It just helps you to see if a site is reachable, not seeing if a site, it helps us to manually query DNS. So it's relating to domain name stuff. So you can see every information relating to domain name. So again, you see the IP address, of the server. For example, google.com, you can see it has this IP address, which is a record. So again, you can go to Google Dig. So Google Dig is its Google DNS lookup. So you'll be able to search any information. So you just need to type whatever, let's say facebook.com. So you can see the A record, which is the public IP address of Facebook. See TXT records, you see name server records, and some of those other things. So it just helps you to see some of these um, domain name information of a particular website. Okay, so we already talked about this. Again, I think I would, you can, when you access, I'll share the links of the to this so that you know which to go through when you're studying, self-studying. But you can see this explains this so well. You can see the physical layer, like we talked about, has to do with like the physical stuff, your laptop, the cables, all of those things. And then data link, which is a MAC address. And so again, this has a really good pictorial representation, so it's easier for you to understand. So what I want to show you here again is the layer. So the application layer, the main function is providing services and interface to application. So example of the protocols under that is HTTP. HTTP is basically telling you that it's like a browser related stuff that you can access via browser. FTP, file transfer protocol. Again, so all these protocols, you need to know that. So I'm not you okay, so understand these different protocols. So the good thing is when you come to this platform and click on each of these, anyone that you see these dotted lines on there, you'll be able to read about it. So you can see hypertext transfer protocol is a protocol that specifies how web browser and web server communicate. So you can read more on that when you click on this FTP. Sorry. Yeah, so the application layer, the presentation layer, data encoding, encryption, compression, all of that happens here. Session layer, establishing, maintaining, and synchronizing sessions. So this is what enables you to establish connection from one host to another. Then transport layer, end-to-end communication. Again, TCP, UDP is under this. The network layer, this is where I told you the IP address is. Then data link layer, the Ethernet, the Wi-Fi, the MAC address, all of that is here. And physical layer, physical data transmission. So this is okay. So sorry, let me just. So looking at this, we talked about DNS, which is domain name system or service. Um, so if you look at this now, the domain name system is a protocol responsible for resolving host names, such as try hack me to their respective IP addresses. So I already explained that. So if, for example, example.com resolves to this. So if you do ns lookup of, if you do ns lookup, you write the command ns lookup and then the host name, it gives you the IP address. So in case you want to get the IP address of any host name, just do ns lookup and that's going to give you the name. So the ns means name server lookup. Uh, so I'm trying to look for the relevant things. So HTTP, accessing the web. So when you fire up your browser, you mainly use HTTP and HTTPS. HTTP hypertext transfer protocol. Then the HTTPS is just the secure one, the secure version of HTTP. Um, Again, that's what it stands for. And the protocol relies on TCP. Okay, it relies on TCP. So some commands or methods that your browser commonly issues to the web servers are get. So again, you will not see this, but at the back end, what is happening when you try to access a website? Me trying to access tryhackme.com is going to, when I go to my browser and type tryhackme.com, it's going to send a get request. So it's saying, get this um, resource, get this resource or this host for Emmanuel. So it receives data from the server, such as HTML file or image. So all of this is HTML, which is why we are seeing this. So it gets this. That's the protocol. That's the is the protocol or what they call it that he uses. And then it's not protocol. That's the what they call it. It's almost like that's like the concepts it uses. So get to retrieve data, then the post allows us to submit new data to the server, such as submitting a form or uploading a file. So when there's a comment section in a blog, you're reading a blog and all of that, and then you want to comment or leave comments, the ability for it to input something into the website is going to use this post. Also, when you're filling a contact us form on the website, is using post because it's taking in information, either you uploading a file into, so they're using post. Then put is used to create a new resource on the server and to update and overwrite an existing information. So if there's maybe let's say there's a database or something that you need to modify, put is going to use put to perform that. Then delete, as the name suggests, is used to delete a specified file or resource on a server. So again, all these are really important, but the most common ones are get and post. That's one we use every day. But yet, these ones also are really um are also used quite often. Excuse me. Uh, so there's a tool called Wireshark. So Wireshark is a very good tool used for. We can see it on Kali Linux. You can use it to sort of examine network connection. So if there's any connectivity issue, most times you see someone say, can you use Wireshark to trace the connectivity? So Wireshark will give you all these details to tell you. So when you see get, it means you're trying to access a resource, which is this host 10.10.41.192. We don't know the domain name, but yeah, the get is you saying over HTTP protocol, which is over the web browser, try to reach this host. So you're seeing this information, you're seeing the user agent, which is the browser, the person is using Mozilla browser, uh, and all of that. And then at the end of this red one is my client. That's, and sorry, when I say client, I mean my workstation trying to reach a server. So this red one is my workstation, and then this one is the server. So it's able to read the server. The server is an Ubuntu server, Ubuntu operating system, which is Linux operating system. On these dates, the content type is text and HTML. So what I'm trying to view on that server is a text or HTML, which is just like normal websites information. So yeah, this and then this here is now showing the content here. So it's showing the details of the website here. This is like the CSS and all of that. Uh, so let's see. So this is networking concepts. Hold on. So another important thing we use is telnet. So we use telnet sometimes to connect to a web server. So in an organization, if you want to know if two hosts or two endpoints, and I mean endpoints or hosts, I mean like two different devices, we don't know their names. That's why we call them hosts. We don't know if it's a Windows computer or a phone or a desktop. We don't know what it is. So we are calling them hosts or endpoints. So when you want to see if they have connectivity or if they can reach each other and transfer files or connect to each other, you use telnet. So you just do telnet and then the name of the IP address of the host you're trying to connect to, and then the port you want to connect to. So if I want to connect, I can say telnet. Let me see if I can telnet to let's see cybersecurity.com on port let's say port 25. Okay, telnet is not enabled here. So an alternative is using PowerShell. So telnet is not enabled there. So you can use TNC. That's cybersecurity.com on dashboards. Again, don't worry about all these things I'm typing. I know they are strange, the commands and all of that. So again, these are things that you learn as you go further in your journey. Again, it's just trying to show you the importance of some of these things. So let's say port 25. So I'm trying to see if I can reach that SC Cyber Safe on that port 25. And so if you can reach, it's going to show true. If not, it's going to show false. So if I can reach it, so that port 25, I think that's the start the DNS. So it's written for what's that SMTP. Yeah, so you can see it's false. So I can't reach it. I can't reach these endpoints on port 25. So it's showing false, which is okay. I mean, you shouldn't be able to reach or telnet into something that's not your own. So I think that's a good result. Um, so I'm trying to see what's relevant again or very okay. So these are protocols. So yeah, another thing you need to understand or you need to know is ports and protocols. So that's a very important part of networking. Um, ports and protocols. So networking is actually very broad. It's not like I told you initially, it's not something that you learn in one day or something that you just master. There are people that like that's their career, that's what they do. They're network security specialist or network engineer or something like that. So but there are some basics you need to know to be able to do your work as a cybersecurity engineer or analyst or whatever part of cybersecurity you are. You need to understand the concept of IP address. You need to know when there's a log and they said this IP address is the source IP, this is the destination IP. You need to understand those things. So but for networking in general, there's a lot of things. So now I'm just seeing that we've not talked about ports. We've not talked about the different types of protocols. But yeah, those are um let me see if it's here. Ports. Mm, okay, so there's network security protocols here. Um, Again, so we had to go through the OSI model first before understanding the ports. And let me see. So I already explained the concept of protocols, but there are different types of protocols like TCP, UDP, HTTP. You can see most of them are ending with P. Those are it's just same protocol, hypertext transfer protocol, transmission control protocol, then the user datagram protocol, and all of that. So those are protocols. It's just showing that there's a way, it's just a standard, like we said, of things or how things are done. So while the ports are, let me see the best way I can give an example. So ports, for example, you hear ports 25, ports 22, which is SSH, and ports. When you hear ports and all of that, let me give an example. So you're in a house, in your house, just use your house for an example. You're in your house and there are different doors in that house. Those doors, let's say they have numbers. Those numbers are ports, and it helps you to identify what happens in those doors. For example, your bedroom is for sleeping. That's the action that happens there. Okay, so that's like the protocol that happens there, and the port number of that SSH, let's say in networking case is 22. Why for that your room number, the room number is maybe room number 5. If someone says, oh, go to room number 5, you already know that room number 5 is a no, is that 5 is place for sleeping. So once someone says go to room number 5, you already know that's bedroom. So the person does not need to say, oh, it's the bedroom. If they say go to room number 5, you know what happens in room number 5. If they say go to room number 10, let's say room number 10 is the kitchen. That's port 10. Let's say port 10. That's not, again, I'm just it's an analogy. So someone says go to port 10, or which is room number 10, which is the kitchen, but the person didn't say kitchen. You already know what happens in the kitchen. That kitchen is for cooking. So that's the protocol. That's what happens there. So maybe the toilet is on the door of the toilet is number 50. So you already know that what happens in the toilet is you want to empty your stomach and all of that. So that's the way ports and protocols work. All of this happen. There's something that happens in all of those rooms. So once you enter there, you know that you want to use it for this specific action. So, for example, port 22 is SSH secure shell. There are other ports there. There's the telnet, which is I think 21 and 21. So there are different other ports there. There's port 443, which is HTTPS. So when you hear port 443, you know that you're trying to access something over the browser. So when you hear 443, port 443 or port 80, port 80 is HTTP, but 443 is the secure one, the HTTPS. So if someone says go to port 80 or room 80, you know that you're going there to do something related to browsing the internet or accessing a URL on the browser. But it's not just secure. That's the 80. But the 443 is the secure room. That one, maybe there's a guard or something. So again, there are things that happen. That's the concept of, I think that's the best way I can explain it. That's the concept of the ports and protocols. Protocols is what happens, what happens there. Why ports is just an identifier of is an easy way of knowing like what happens in those places, or it's an easy identifier instead of with the names. So So you can see here there's a request and a response via HTTP. So an HTTP request is made by a user agent, a browser, or any application sending requests through a web API. It's vice versa in the case of the response. The request aims to access some resources on the remote web server, which is then responded to by the web browser. The figure below shows a web browser sending an HTTP request to a web server listening at TCP port 18. So this is a laptop accessing a web browser, and then you're trying to access a website on which is you're trying to access a website because you're seeing port 80, so you already know that it's like a website related stuff. If it's 4432, it's a website related stuff, but it's secure. Then also there's going to be a HTTP response back to your browser, which is why if you go on your browser and type any website, you will be able to see it. Is because it's using that port 80 or port 443 in this case, because it's secure, it's using ports. You can see the connection is secure, it's using port 443. So there's also port 21, which is seeing FTP. So this FTP server is a file transfer protocol server. So it's just to transfer different types of files. So yeah, that's a file transfer server. So when you see port 21, if someone says a port 21 is open in this network, it means there's a file transfer server there that's used to transfer files or store files, and it's open. So I think these are some of the concepts I would explain. I think that brings us to the end of today's session. Again, networking is a lot, but we can start from one place. I would recommend um so just let me give you as an assignment just so that you can go back. So your first assignment, you can take note of this. Your first assignment will be to create an account on tryhackme.com if you don't already have. But if you have, it's fine. If you don't have, just go to tryhackme.com, sign up, create an account, then you come to the search bar here and just search for networking. So once you search for networking, you can see there, it looks like there are 95 rooms relating to networking. You can view all if you want. Um, So when you view all, you would see here you're seeing introductory networking. So this is easy. Then when you go through all of this, you can click on it. When you click on it, it will take you to the learning, the part where you learn and answer questions. So you can see here, after every stuff, you can see let's get started. So you check it. Once you check it, it marks it. Then you go to the next one. You read. Again, most of these things are short, but they give you some. They'll show you videos, but in the end, you have to answer the question, and the question is mostly from what was stated here. So it's easy for you to test yourself almost immediately. But let me go back to, yeah, so here you can see what's networking essential, networking concepts, uh, OSI model. Um, so some of these network analysis, TCP dump. So again, because this is introductory, I'm sure we would have more. Maybe I'm not sure. Maybe it's in this bootcamp, but we'll have more if you want more dedicated sessions. Because there are some people that reach out to us saying, "Oh, we want dedicated trainings to maybe for I want to write." My Cisco CCNA or CompTIA Network Plus and all of that. So there's dedicated training which we do for those specific ones. So we go from the beginning to the end. But most of what we are doing now is just introducing you to the concepts and letting you know why they are important. But again, um, because this is very broad, it can take almost 3 months to fully go through all the concepts of networking. Yeah, so this just helps you. You can see easy. You go through all of the easy concepts. Okay, some of these are not network based, but just take the one that has network related stuff, and then yeah. So the assignments: sign in to try hack me. Sign up to try hack me, and then do the do this networking basics. So do networking basics, do introductory networking, like every task that is there, you must make sure that it's being done. All the answers there are being filled by you. You can see here DNS, this domain name system, you fill it in, then click check. So yeah, so I think that's the assignment for that's the assignment. So just do everything in what is networking, and then intro to networking. Sorry, excuse me. Okay, yeah. So this is the end of today's session. So we've gone through a lot, so we need time to digest that. So please go through that and do your assignment, and then submit before when is the deadline? Yeah, so just submit it before next week Saturday. So by submission, the way, so once you submit, or just once you've done it, I'll tell you how to submit it on the group. I'll find out the best way to submit it. Uh, either I get you to show me, or but yeah, just do it. When next we meet, would can just say call anyone and tell you to show me the assignment, and with the expectation that you've done it. Yeah.
Can they do it screenshot? They should screenshot the assignment.
Yes, so that's also you can screenshot it, and yeah, you can. I think yeah. So Vivian will communicate how you do that, how you would submit the assignment, basically.
All right. Thank you all for joining this session. Have a good night's rest. Thank you, Emmanuel.
Yeah, thank you very much.
Yeah. Bye.